All right. This evening I'm going to talk to you all about machine learning model training and deployment using infrastructure as code. In other words, how to get people to actually use the wonderful models that you're building. And I'm really going to start by just spending most of the time talking about an actual problem and the solution to it, and actually talk very little about actual infrastructure as code. So the problem statement starts with the task of automating a manual process, and this is real world too. From the government space, where contract analysts take about 2 weeks usually to review end user license agreements or EULAs. It's those things we all blindly accept when we get a new operating system update or we're downloading new software. It would take them 14 days, 2 weeks to review those things. And they were wondering if a machine learning model could use natural language processing to parse through all those EULA clauses and then predict ones that are potentially non compliant for federal law. And then an additional requirement was like, could that model be invoked by a web application, like some kind of UI that would automate the process all these contract analysts were doing with like emails and Excel and things like of that nature. And so we built something. These are some screenshots here, and it's just a web app where they would upload documents. You can see on the right hand side, there's a bunch of PDFs and Word docs that are uploaded, and those all get scanned, and all the clauses of these end user licensing agreements get broken out, like you can see here for one of the docs. And then the idea is like in this web app, it would be calling a model to predict whether or not each clause was compliant or not. If one was potentially not compliant, it'd be flagged, like you can see in the background here, is yellow. And then they could click on it, get a little modal that might tell them, what particular words or phrases flagged it as non-compliant. So it's not just a black box model; it's a little bit interpretable. And then they could, of course, provide feedback, like agree or disagree with the prediction, and that just would support model retraining to prevent the model from drifting in the future. So behind the scenes, though, is where I want to talk about this model being deployed and using infrastructure as code. So the idea is to have a model as a service. So the architecture for this application here on the right side is that web app. It's just built with Python and Docker and using Redis as a service worker to communicate with that model, which was an API over HTTPS. Everything on the left-hand side here, which looks a bit complicated, is what you could deploy in Amazon Web Services using infrastructure as code. And although it does look complicated, it's really not when you use infrastructure as code. It's when you're writing your code in a language like Python or TypeScript, for example. But the idea, it really just starts down here in the bottom with that little brain looking icon. The idea is you're going to write some infrastructure as code to give yourself a remote compute environment where you can train a model or models and with as much CPU or GPU as you want. And then Amazon will just take care of the process of taking that model, say your best one, and putting it into an object storage for you, and then handling the task of deploying it to a web server, putting a reverse proxy in front of it and a load balancer, and then giving you the ability to write some additional custom code to pre-process, post-process, input and output of that model, making it all available as an API. It's definitely complicated. It's a high-level diagram, but to make it as simple as possible, the idea is you want to train and deploy a model so that you can use it as an API. So for example, here I've got like Python code, pseudocode, but then also curl. The idea is like you've got an endpoint and you want to send to it some text, like a clause. Like for instance, it's just the phrase, this is a test. This would actually be like a EULA clause. And you want to be able to get back as a response from this API what the prediction was, what the likelihood of that prediction being what it is, and then finally an explanation, which is really just base64 encoded HTML of the table that you saw here explaining how the prediction was made. So that is really like, this is what you would actually want to solve that problem that the government had. And it might seem daunting, like how would you build something like this, stitch all these different things together to be able to provide basically this functionality to a web application, a web client? And the answer is just with infrastructure as code. So like I said earlier, the idea is you want to use all these different cloud resources. Like you can see down here, like there's got to be a space, a box for you to host models. There's got to be like an API service to give you that endpoint. In Amazon, you would have something called Lambda functions where it's custom code to control how that model is invoked. And that's all going to be used by the client application. Setting all that up you can write Python code or TypeScript or Java or I think even C Sharp to create that infrastructure. And this is the actual code I use to make. It's like not all of it, but at a high level, it's what provisions everything that you see back here. And the benefit is that it really like this tool, it's called the AWS CDK, the Cloud Developer Kit, really democratizes for us data scientists or people that know a language like Python what is otherwise a really difficult task of like setting up all this infrastructure. You can find an example of this exact workflow, which is a dime a dozen, on their GitHub for free. It's just there. You just got to tailor it to your own needs.
I do have questions. This is extremely cool. So, I've had some experience working directly with the AWS SAM sort of specification or with CloudFormation directly, just writing their YAML files to provision these resources. Do you find that do you find that working with the Python CDK is a better experience?
Yeah, I'd say definitely. The CDK, like Sam, does use CloudFormation behind the scenes, so you can actually run commands to just generate the equivalent CloudFormation templates in YAML or JSON for your Python or TypeScript code. But I think the additive benefit here is that you can be much more concise. You can write 10 lines of Python to generate like 150 lines of YAML. But then you also get the ability to have IntelliSense in your IDE and code auto completion. And you can also then write unit and integration test for the code that's provisioning your infrastructure. So you can write assertions to make sure certain conditions you want in place, like say a database using like secrets manager for a password or something, or having a certain password policy. You can bake those into your test. And then like just like you could with CloudFormation templates, you could source it all in a Git repository too.
That is fantastic. Yeah, it is a pain to put those templates together and then just hope you've got everything together so that when you go, Sam build, Sam deploy. Okay, that didn't work. Sam build, Sam deploy again, please.
Yeah.
Okay, that didn't work. Yeah, that's fantastic.
Yeah. The one downside is there's not one like 100% of the stuff you can do in CloudFormation isn't supported yet in the CDK. Um, with like their higher level constructs, but you can get really low level with the code and do anything you could do in CloudFormation. But at that point, it's like you might as well be doing it in CloudFormation.
Yeah, I guess one more question. Do you find that Lambda is enough for most use cases, or do you ever find that like the amount of space or the time limit is an issue? And like I imagine anything where you want it to be really accessible to users and respond in a timely fashion, you wouldn't want it running longer than 15 minutes anyways. But for most of the things you have to do you think that's what you reach for?
Yeah, it's like the Swiss Army knife, in my mind. Although with AWS SageMaker, the models when they're deployed, they'll put them in an EC2 instance for you. That's always running. But you could like forego that and put the model in a Lambda function now that they even support Docker containers. But it's harder to get the compute resources you need sometimes for a model in a Lambda function. So sometimes an EC2 instance or a fleet of them, like in an auto scaling group, could be better.
So useful. Thank you so much.